I would have it at the 1% significance level. And I would darn near have it at the 0.1% significance level. Okay?
You, sir, are alive.
You sir. Alright, how are we feeling on this? Good? Good? I think I just have one more example for the independence. And that's, we can keep going, right? We don't need a break, do we?
Yeah.
Ooh,
That's it?
That's it.
Yeah.
Camera down.
Oh, boy. There we go, okay. Alright, this is a fun little, okay. So, okay, so we're back to the chi-square test for independence. We put them on a table, the same way we did for differences in population proportions. We test whether two factors are independent of each other, meaning does one depend on each other? In our first example, we found yes, opinion depends on location. So they're not independent. We have a certain number of rows, columns. Our null hypothesis is the factors are independent. Doesn't matter which campus you're at, your opinion will be the same as everyone's. Alternative, the factors are not independent. Okay, this summary is the same. We show a table of observed, show a table of expected, compute the chi-squared. Observed minus expected divided by expected, observed minus expected squared divided by expected. Add also all up, apply the decision rule either with a critical value or the p-value conversion. Alright, check it out. Check it out. Situation. This table shows the grades for a random sample of business statistics students at Bandon University over the past 5 years, along with measures of class attendance. We want to test the hypothesis that grade and class attendance are independent. Alright, grade and class attendance are independent. What does that mean?
That means
Grade and class attendance are independent.
that your student grade does not depend on how much you come to or not come to class.
Exactly. Right? If they were, if that crazy notion were true, right, then coming to class would give no predictive ability about whether or not you get an A, B, C, D, whatever in the class. So the null hypothesis is that these factors are independent. Now we all know that's not true, right? 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 I'd say hopefully. Alright, but let's just get some mathematical statistical evidence to prove that in fact your grade does depend on whether or not you come to class. So we took a random sample of students, alright, and we looked at the grade they got, A, B, C, or D, and we grouped them into students who came to class who missed 3 or fewer classes. So these are the students who came to class most, and these are students who missed 4 or more classes. Alright, so of the students who came to class, 160 got A's. Of the 300, look at it this way. Alright, so, wait a minute. Okay, of the students who got A's, we had 300, wait, I'm saying this wrong. We had 340 students get A's. 160 of those came to class almost all the time. 180 of those did not come to class. Same type of thing for B's, C's, D's. Let me draw your attention to these row totals here. See the students who came to class, 460, and the students who missed a lot of class, 540. So out of 1,000 students, did we have more students who came to class or more students who missed class? Missed class, okay. Alright, so maybe this is just the kind of college where you don't go to class, it's a sports school, you gotta keep people going to their practices and games and stuff, or they're going to the parties after the games. It's just, maybe it's a culture where not a lot of people go to class all the time. So the reason I point that out is you see how we had more students in this category here, students who didn't come to class and still got an A, and we had fewer students who came to class and got an A. The reason for that is because we have more students who don't come to class, overall.
But it follows the same pattern as the lower grades too. So more students got worse grades, got a D.
Yeah, so we have more students in all of these, in this whole row, right? Right, and it is, so I point that out because I don't want you to get confused there. That doesn't mean that not coming to class is a good thing for you. Alright, just so we're clear on that. Alright, the reason why these are more is because we have more students in general who don't come to class. Now let's look at some observed. Okay, so let's put in, what did I have? Yeah. Okay, so let's calculate our expected frequencies. So how many students would we expect, of these students who came to class, how many we would expect to get an A in this cell?
170.
This one here?
Yeah. Right.
Alright, so this, how do we calculate expected value here, Calvin?
We divide, it says it right there, right? 340 divided by 1,000.
Yeah.
And then, times 460.
Exactly. Alright, so we had 340 students total who got A's. What proportion of the grand total is that? Well, so 340 divided by 1,000, it's 34%. Alright, let's multiply that by the number of, the row total here. The number of students, the total pool of students who came to class a lot. And we get an expected value of 156. Alright, here we get an expected value of 183. So on and so forth. Let's look at these observed, and now let's stay here for a minute. I feel like I'm rushing through this example.
Is it different?
Alright, so, how about, here, somebody walk me through this. How did I get this 101.2?
220 divided by 1,000 times 460.
Times 460, exactly, alright. And then tell me, interpret that for me. Say 101.2 students
Are expected to get a grade of a C if they miss 3 or fewer days.
Perfect. Alright. How about this one? Interpret this for us, Catherine. How do we get this 143, and then tell us the interpretation?
265 divided by 1,000 times, I can't say that, 540 gives you 143.1. So it is expected that 143.1 students get a B if they missed 4 or more.
Exactly. Alright, and you got this, Henry, right?
Yes.
Alright, so let's look at our observed minus observed compared to expected. Alright, what's going on in this first row here? Of the students who came to class and got A's, this is observed 160, expected is 156.4. Tell me which is higher, how does that bode for our hypothesis?
You observe more people getting an A than expected that missed 3 or fewer days.
Okay, and this expected under what assumption?
That the population is,
What's the null hypothesis?
that 156.4 people will get an A if they miss 3 or 4 fewer classes.
No, what's the null hypothesis? Go back to the null hypothesis, what is it?
That's a true. Oh, no, that grade is independent.
Yeah.
Grade is independent,
There.
also known as doesn't matter if you come to class.
Yeah, okay.
So assuming it doesn't matter if you come to class, how many A's would we have expected of this group of students? 156.4. How many did we actually see?
160.
So we saw more. So that's,
Doesn't matter.
wait a minute, no, wait.
It does matter.
It does
Oh, it
matter.
does, okay.
This is evidence that it does matter, right?
Mm.
Because the students who came to class more outperformed the expectation,
Oh, yeah, okay, I get it.
assuming it doesn't matter. Alright, how about the students who missed class? What's going on here? Observed compared to expected.
We observed that they received, 180 students received an A, and we were wrong by thinking that if they missed class, they would get a higher grade. Well, alright. Okay, so we expected that 183 students would get an A if they missed 4 or more classes. But when we observed it, we saw that 180 students got an A, so it was, we were off by saying,
Okay, so remember this, how many times they missed class in a way doesn't factor into our expectation. Our expectation is, doesn't matter if you missed class.
oh, it doesn't matter.
Doesn't matter, and so our expectation, our assumption, our projection under that assumption is we would expect 183.6 students to get A's. What might be something that would explain why we had fewer A's in this category?
Because they missed 4 more days of class.
Because they missed class. Okay, so we had lower than expected A's among the students who missed class, and we had higher than expected A's among the students who came to class. Alright, so that's evidence that the null hypothesis might be wrong. And the null hypothesis, again, doesn't matter if you come to class. You with me there?
Mhm.
Let's just do the same thing with the D's, just so we just really ingrain this. So can someone give me the interpretation, observed, expected, and what that might mean?
We expected 80.5 students to get a D if they came to class 3 or fewer times, and we observed 75.
Okay? What does that observation tell you?
That if you miss, well, it doesn't matter, actually. It doesn't matter if you come to class or not.
For the first part, it doesn't matter if you come to class. But now that you've observed it, yeah, when you explained it the first time,
Yeah.
you didn't need to throw in
I
number of
remember.
classes. So keep that out of your explanation the first time. So try it once again.
We expected 8.5 people to miss class, or 80.5 people to get a D if they did not come to class, and we observed 75. Or just keep the whole class out of it.
Keep class attendance out of the first part of your
We
explanation.
expected 80.5 people to get a D, and we observed that only 75 students.
Yes. Okay, so we expected 85 to get a D, and we observed fewer
Fewer.
than we expected. Now, tell me what might explain why we observed fewer D's in this cell.
We observed fewer Ds because they missed 3 or fewer classes.
That might be why
It
we
was the
observed
class
difference. That might be why there's a difference.
So really just we're saving for the end, kind of. Gotcha.
Save it till the end. Okay, alright. One more. I need interpretation here and possible explanation of why they're different. Take it away, Henry.
We expected 94.5 students to get a D, but we observed 100 getting a D.
Okay, now we expected, tell me about that expected. Why did you expect 94 to get a D?
Because they missed 4 more classes?
Yeah.
No?
Yeah, we expected 94 to get a D because our null hypothesis said what?
Says that it doesn't matter if they come to class.
Doesn't matter if you come to class. So under that assumption, we expect 94.5 to get a D. Now, did we observe that?
No, we observed 100,
Okay,
so that means
what might that mean?
that it does matter.
That might be evidence that it does matter.
Evidence that it does
Yeah.
matter. Or
We,
what?
so these are all the students who missed class. And more of those students got Ds than we would expect. Can I belabor that point just a tiny bit longer? Is that okay? Let's do this part, let's do this again. Just these again. Alright, so tell me what you expected, and under what assumption do you expect that many A's? Kelly.
Okay, so we expected that 156.4 students would get an A. We observed that 160 students got an A.
Okay, now, why did you expect 156 students to get an A? Why do you expect that?
Because the null hypothesis that says that attendance doesn't matter.
Yep, so attendance is just a straight proportion of the total, all right? What did we observe?
We observed that 160 students got an A.
Yes, so what might that be evidence of? What might that prove?
It might prove that attendance actually does matter.
Yes, so we might use this as evidence to reject the null hypothesis. Yes, okay, now let's do this one, last one. Mike, tell me about this expected, why did you expect
We
it?
expected 183.6 students to get an A because the null hypothesis says it doesn't matter if you come to class.
Yes.
We observed 180 students got an A because it might prove that coming to class does matter.
Yeah, we saw fewer students than we expected of this group who missed class. Okay, so we're gonna do for each cell, we're gonna take observed minus expected squared divided by expected. We're gonna add that up 8 times. What is our degree of freedom in this case?
One time.
Degrees of freedom equals row total minus 1 times column total minus 1.
1 time 3.
3? Yeah, I think that's right. Total number of columns is 4, minus 1 is 3, rows is 2, 2 times 1 is 3 times 1 is 3. Alright, let's do a 5% significance level. Alright, 0.05. Let's check the back of the book. Tell me what you get for a critical value.
5.991.
Is it the same again?
7.815.
Yeah.
7.89.
It's
Yeah,
7.
because it's 3 now, right?
Yeah.
Yeah, 7.8.
Yeah, okay. So 7.8, what?
1.5.
1.5. Okay, so when we add all of these up, we're gonna see if the critical chi-square test statistic is above 7.8, in which case we reject the null, or if it's not, we fail to reject. Turns out, when we calculate the chi-squared test statistic for each cell, and we add them up, we get a chi-squared test statistic of 1.002. Brings tears to my eyes.
I'm gonna present this to the school board.
What?
I am
What just
90
happened
I
here?
am 95% confident that I don't have to come to class.
What is our interpretation here?
That,
So first of all, do we reject or fail to reject?
Fail.
failed to
We fail to reject, and what are we failing to reject?
That
What's that?
it doesn't matter.
Yeah, we're failing to reject the null hypothesis that it doesn't matter if we come to class.
So it doesn't matter.
The kids are either really smart or the school's really easy. One or the other.
I mean, like, because I had a question about the D, the guys that got the Ds. So, like, with the ones that missed 4 or more classes, you actually had, no, the first one, the ones that missed fewer classes. Okay, never mind. I'm getting.
I know what you're saying. That the kids that got A's and B's were and they missed more classes, it didn't matter.
Yeah, for the Ds, it doesn't really matter, right? If they missed.
The higher
come
grades-
Because they just don't, pretty much.
It's the same thing, right? We would, under the null hypothesis that it doesn't matter, we would expect 85.
Mhm.
But we observed fewer.
Yeah.
What might explain why we observed fewer? Because this is the group that came to class.
Mhm.
Down
Oh.
here, we expected 94, but we observed more.
More.
Why might have more students in this cell gotten a bad grade? Because they didn't come to class. But it turns out that that deviation is not enough to prove that you must come to class. That deviation is not enough to reject the null hypothesis that it doesn't matter if you come to class. And the way we said it doesn't matter if you come to class is we said grade and class attendance are independent. They do not, one does not depend on the other.
It could be a hybrid, it could be like an online class and an actual class.
Yeah, I think that this is an example from your textbook. I think they just made up these numbers just to be funny. So, yeah. Any questions on that? So, what I think you're gonna want to do is put this in Excel, or do some of the homework problems, and just put them in Excel, so that you can calculate the observed minus expected squared, add up the whole test statistic, and your quiz will just be a couple of these. In fact, it will be one test for proportion differences, and one test for independence. And I think it's, as I recall, it's either exactly like a couple of the homework problems, or very similar to the homework problems. Or actually, no, I don't remember. No, it's not like your homework problems. It's not like word for word like your homework problem, but it's the same thing. Just figure out a way to get them in Excel, figure out a way that works for you. And I think actually the Excel homework is optional this week. It says that on the syllabus, right?
Oh no, only 1, 2, question 1, 2, and 3, the rest are optional.
Yeah, question 1, 2, and 3, do 1, 2, and 3, the rest are optional because I've had students tell me that it's easier just to do it by plugging the formulas in manually. Then it's not much help, the questions you get, or the Excel exercises you get. But if they work for you, then fine, check them out and do them.
I only remember because I saw 10 questions and I panicked, and then I saw option, I was like, oh, thank God.
Alright, great work. I'll see you next week, we'll review for the final.
7:30 next week too?
No, regular time next week. Yeah, regular time next week, and we'll just go through quiz by quiz. Oh, and one thing I will say, that I would take this next week to start reviewing old quizzes. Because the key to doing well on the final is just knowing all those quiz questions.
Is it still, is it open book the final?
Yep, all open book, open everything. You'll come here, we'll take it in class. You can use any resources except each other.
So we use our slides and all that stuff that we have?
Slides, whatever you want.
Cool.
But still, it's challenging because you're gonna need to think on, not on your feet, so to speak, but you're just gonna need to do 10 questions and get the correct answers. So I would try calculating out past quiz questions.
Gotcha.
The closer you can be to being comfortable with all of those quiz questions, when you walk in next week, the more next week will just feel like an easy review.
So next week is the review for the final?
Next week is the review of the final, and we'll go through question by question. We'll try to go through some of them quickly, because we can't go through all of them in 3 hours.
Yeah, the camera roll?
I'm not sure. Yeah, maybe not, I'm not sure about the camera. Alright, see you next week. Good work. Alright, see ya.